In question 1 of this exercise, we have to find the roots of the following quadratic equations. So there are 4 quadratic equations and we have to find the roots of each one of them if they exist by the method of completing the square. So we have to use the method of completing the square to find the roots of each quadratic equation. So let's start with the first part. So in the first part, the quadratic equation is 2x square minus 7x plus 3 equal to 0. Now, how can you complete the square for this quadratic equation? So the x square term is 2x square, which is not a perfect square. So what we need is for this term to be a perfect square. So there are 2 ways to do it. One way is that you divide the whole equation by 2 so that this term becomes x square. So in that case, you can write the equation as x square minus 7 by 2x plus 3 by 2 equal to 0. And now it's possible to complete the square because you have the first term as a perfect square. The other way is that you multiply this equation by a certain multiplier so that 2x square becomes a perfect square. What you can do is you can multiply this equation by 2 so that 2x square becomes 4x square. And in that case, the equation can be written as 4x square minus 14x plus 6 equal to 0. So these are the 2 ways in which you can turn the first term into a perfect square, and you can use now either of these forms to complete the square and solve the equation. So what I'm going to do is I'm going to use the first form in this case and complete the square for this first form. So the equation now is x square minus 7 by 2x plus 3 by 2 equal to 0. So we can write this as x square, so a square minus 2ab. So I will try to write minus 7 by 2x as minus 2ab. So minus 2 times a, which is x, the first term, a square. So corresponding to a square we have x, and 2 times x, and we want 7 by 2x. So what should I write here? What multiplier should I use here? So the whole term becomes 7 by 2x. So I can write 7 by 4. So you can now verify that minus 2 times x times 7 by 4 is minus 7 by 2x. So now what do we have? We have an a square term. We have a minus 2ab term. And what we need now to complete the square is a b square term, where b is 7 by 4. So now I can introduce this new term 7 by 4 whole square, and this combination of terms will now be a perfect square. But now because I have introduced this term, I will also need to subtract it. So let's subtract it. So we have minus 7 by 4 whole square, and then we have this original constant term 3 by 2. So 3 by 2 equal to 0. So this is how I can complete the square. So now this part, this combination of 3 terms, this will become a perfect square. So let's write it here. So this will become x minus 7 by 4 whole square. And then I'm left with minus 7 by 4 whole square plus 3 by 2. So minus 49 by 16 plus 3 by 2. This is equal to 0. So this is how I can modify the original equation by completing the square. Now from here we can write x minus 7 by 4 whole square is equal to 49 by 16 minus 3 by 2. So minus 3 by 2 can be written as minus 24 by 16. So the right side will become 25 by 16. And you can now see that this is a perfect square of a rational number. So if I take square roots on both sides now, I will get x minus 7 by 4 is equal to plus minus, or actually let's write them separately, plus 5 by 4 and minus 5 by 4. So finally from here we can find the value of x. So the one value of x will correspond to the plus 5 by 4. So that will be x equal to 7 by 4 plus 5 by 4. So that's 12 by 4 or 3. The second value will be x equal to 7 by 4 minus 5 by 4 or 2 by 4 or half. So the two roots of the first equation are 3, x equal to 3 and x equal to half. So let's write them here. The two roots are 3 and half. And with that we've solved part 1. Now let's go to part 2. In part 3, the equation is 4x square plus 4 root 3x plus 3. So the first term, the quadratic term, the x square term is already a perfect square. So we don't need to modify this equation. We can directly start the process of completing the square. So 4x square can be written as 2x whole square, and this is of the form a square. So now let's express the second term 4 root 3x in the form 2ab. So we can write this as 2 times 2x, a is 2x, so 2 times 2x. So what multiplier should I have now so that I get 4 root 3x? So 2 times 2x is 4x, so I need a root 3 factor to get 4 root 3x. So now this term is of the form 2ab, and now I need b square, and b is root 3, so b square is 3, and I see that I already have a 3 here, so that's the term b square, and this is equal to 0. So we don't need to introduce any new term now. These three terms already form a perfect square, and that perfect square is 2x plus root 3 whole square. And you can verify that if you square 2x plus root 3, you will get 4x square plus 4 root 3x plus 3. So 2x plus root 3 whole square is equal to 0. This is how we can rewrite this equation. So this means that 2x plus root 3 is equal to 0. And from here we have x equal to minus root 3 by 2. Minus root 3 by 2. So this equation actually has two roots which are identical. Both roots are minus root 3 by 2. So let's write this here, minus root 3 by 2 and minus root 3 by 2. Now that completes part 3. Now let's go to part 4. 2 of this exercise says, find the roots of the quadratic equations given in question 1 by applying the quadratic formula. So let's pull the questions from question 1. So these were the 4 quadratic equations which we solved in question 1 by the method of completing the square. In this question we have to solve the same equations again, but this time we have to apply the quadratic formula to solve these equations. So let's do that. Let's start with part 1. So in part 1 the equation is 2x square minus 7x plus 3 equal to 0. And let's first write the coefficients of this equation. So a, the coefficient of x square, is equal to 2, b, the coefficient of x is equal to minus 7, and c, the constant term, is equal to 3. Now we can apply the quadratic formula. So we can say that x is equal to minus b plus minus root b square minus 4ac by 2a. So this is the quadratic formula. So this is equal to minus b, which is plus 7. So minus of minus 7, that's plus 7, plus minus root of b square, so minus 7 square, which is 49, minus 4 times a, which is 2, times c, which is 3, by 2a, or 2 times 2. So what is this equal to? This is equal to 7 plus minus root of 49 minus 4 into 2 into 3, so that's 4 into 2 is 8, 8 into 3 is 24, so 49 minus 24 by 2 times 2 is equal to 4. So this is equal to 7 plus minus root of 25, 49 minus 24 is 25, so 7 plus minus root 25 by 4, and this is equal to 7 plus minus 5 by 4. So now if we select the plus sign, we will get 7 plus 5 by 4, and if we select the minus sign, we will get 7 minus 5 by 4. So 7 plus 5 by 4 is equal to 12 by 4 or 3. 7 minus 5 by 4 is equal to 2 by 4 or half. And this matches with what we found by the method of completing the square. So we have solved equation 1 using the quadratic formula. Now let's go to equation 2. So equation 2 is, in part 2, is 2x square plus x minus 4 is equal to 0. So let's first write the coefficients of this equation. So a, the coefficient of x square is 2, b, which is the coefficient of x, is equal to 1, and c, which is the constant term, is equal to minus 4. And now let's apply the quadratic formula. So we'll get x is equal to minus b plus minus b square minus 4ac, the root of this, by 2a. Now let's plug in the values. So minus b will be equal to minus 1, then plus minus root of b square, so b square is 1 square or 1, minus 4ac, so 4 times a, which is 2, times c, which is minus 4, and then in the denominator we have 2a, or 2 times 2. So this is equal to minus 1 plus minus root of 1 minus 4 into 2 is 8, minus 8 minus times minus 4 is plus 32. So 1 plus 32 by 2 times 2 is equal to 4. So what is this equal to? So this is equal to minus 1 plus minus root of 33 by 4. So if I take the plus sign, I get one root, which is minus 1 plus root 33 by 4. And if I take the minus sign, I get the second root, which is minus 1 minus root 33 by 4. And this is what we got by applying the method of completing the square in the previous question. So now we have solved part 2 by the method of applying the quadratic formula. Now let's go to part 3. In question 3 of this exercise asks us to find the roots of the following equations. So there are two parts in this question, and both the equations are not in the standard quadratic form. So we have to solve them, and we have to find the values of x which satisfy these equations. So let's start with the first part. So in the first part, the equation is x minus 1 by x equal to 3. And we're also told that x is not equal to 0, because if x is equal to 0, then this term 1 by x will be undefined. So let's modify this equation and write it in standard quadratic form. So if we take, so we have x and we have 1 minus x here. So if we take the LCM for the two terms on the left hand side, we get x in the denominator, we get x square from this first term x, and we get minus 1 from this numerator. So we have x square minus 1 by x is equal to 3. And now if I cross multiply x to the right side, I will get x square minus 1 equal to 3x, or x square minus 3x minus 1 equal to 0. So now this equation is in the standard quadratic form with the coefficients as a equal to 1, b equal to minus 3, and c equal to minus 1. So a is the coefficient of x square, b is the coefficient of x, and c is the constant term. Now what we can do is we can apply the quadratic formula and find the roots of this equation. So the roots will be x equal to minus b plus minus root of the discriminant b square minus 4ac by 2a. So let's plug in the values for a, b and c. So we'll get minus b, which is plus 3, because b is minus 3, so minus b is plus 3, plus minus root of, so we have now b square, which is 9, minus 4ac, so 4 times a is 1 times c is minus 1, and then in the denominator we'll have 2 times a, or 2 times 1. So this is what we get. So now let's evaluate what these roots are. So we have 3 plus minus root of, we have 9 minus 4 times minus 1, so that's plus 4. So 9 plus 4 is 13. So 3 plus minus root 13 by 2. So these are the two roots of this equation. So one root corresponds to the plus sign, so that's 3 plus root 13 by 2. So that's one root, x equal to 3 plus root 13 by 2, and the other root corresponds to the minus sign, so that will be 3 minus root 13 by 2. So these are the two roots of the equation in part 1. Now let's find the values of x which satisfy the equation in part 2. So in part 2, the equation is 1 by x plus 4 minus 1 by x minus 7 equal to 11 by 30, and we're told that x is not equal to minus 4 or 7, because if x equal to minus 4, then this first term will become 0, undefined, because the denominator becomes 0, and if x is equal to 7, then the second term will become undefined, because the denominator x minus 7 will become 0. So x cannot take these values, and now we have to find the values of x which satisfy this equation. So once again, this is not written in the standard quadratic form, so let's first convert it and rewrite this as an equation in quadratic form. So we have two terms on the left hand side, so let's take the LCM of the denominators. So we will get x plus 4 times x minus 7, and then corresponding to the first numerator 1, we will get x minus 7, and then minus corresponding to the second numerator 1, we will get x plus 4. So this is how we can combine the two terms on the left hand side, and this is equal to 11 by 30 on the right hand side. So now let's simplify and see what we get. So in the numerator, we'll get x minus 7 minus x plus 4. So the x terms cancel out, and we're left with minus 7 minus 4. So that's minus 11 by x plus 4 times x minus 7 equal to 11 by 30. So we can divide both sides by 11. So we'll get minus 1 here and we'll get 1 here. And now we can cross multiply. So on the left hand side, we can multiply minus 1 with 30. So we'll get minus 30. And on the right hand side, we can multiply 1 with this product of binomials. So we'll get x plus 4 times x minus 7. Now let's expand this product of binomials on the right hand side, so that this will be x times x. So that's x square. Then x times minus 7, minus 7x, and 4 times x is 4x. So minus 7x plus 4x is minus 3x. And then we have plus 4 times minus 7 is minus 28. So this is equal to minus 30. And now let's shift this minus 30 to the right side. So minus 30 becomes plus 30, and plus 30 minus 28 is plus 2. So this equation can be finally written as x square minus 3x plus 2 equal to 0. So let me rewrite it again here. So we modified this whole equation into this quadratic equation x square minus 3x plus 2 equal to 0. Now we can solve it by applying the quadratic formula, or we can solve it by completing the square, or in this case we can also easily factorize this quadratic expression by splitting minus 3x as minus 2x minus x, and then plus 2 equal to 0. So from the first pair of terms we get x times x minus 2, and from the second pair of terms we get minus 1 times x minus 2. So this is equal to 0, and this means that x minus 1 times x minus 2 is equal to 0. So this is how we can factorize this quadratic expression. So from here we can easily conclude that the roots are x equal to 1 and x equal to 2. So the two roots of this equation in the second part are x equal to 1 and x equal to 2, and that solves part 2 of this question. 4 of this exercise, the problem statement says the sum of the reciprocals of Rahman's age in years 3 years ago and 5 years from now is 1 by 3. Find his present age. So the unknown in this case is Rahman's present age. So let's assume that his present age is x years. So let's say Rahman's present age is x years, and we have to find the value of x. So we are told that the sum of the reciprocals of his ages 3 years ago and 5 years from now. So Rahman's age 3 years ago will be x minus 3 years, because his present age is x. So 3 years ago his age would have been x minus 3 years, and his age 5 years from now. So his age 5 years from now will be x plus 5, because his present age is x. So 5 years from now his age will be x plus 5 years, right? And now what we're told is that the sum of the reciprocals of these two ages is 1 by 3, and from here we get our equation. So the reciprocal of x minus 3 is 1 by x minus 3. The reciprocal of x plus 5 is 1 by x plus 5, and we are told that the sum of these reciprocals is equal to 1 by 3. So this is how we can set up the equation corresponding to this situation, and the main step in this problem is actually setting up this equation, and from this point onward solving this equation is straightforward. The main part of this problem, the main part of solving it, is actually setting up this equation correctly. Now let's solve this equation. So let's take the LCM of the denominators x minus 3 and x plus 5 and combine the two terms on the left hand side. So we will get x minus 3 times x plus 5, and then corresponding to this one we will get x plus 5, the second denominator, and then corresponding to this one we will get x minus 3, the first denominator, and the sum of these two. So this is how we can combine the two fractional terms on the left hand side, and this is equal to 1 by 3 on the right side. So let's simplify this and see what we get. So in the numerator we have x plus 5 plus x minus 3. So that's 2x plus 5 minus 3 is 2. So 2x plus 2 by x minus 3 times x plus 5. This is equal to 1 by 3. Now let's cross multiply. So 3 multiplies with 2x plus 2, and this gives us 6x plus 6. And on the right side I get x minus 3 x plus 5 times 1. So this becomes x minus 3 times x plus 5. So let's expand the product on the right hand side. So this will be x times x, so that's x square, and then we have 5x minus 3x, so that's 2x, and then we have minus 3 times 5 is minus 15, and this is equal to 6x plus 6 on the left hand side. And now let's combine all the terms. So we will get x square, and then we have 2x here, and if we take the 6x to the right side we get minus 4x, and then we have minus 15, and if we take the 6 to the right side we get minus 21. So x square minus 4x minus 21 equal to 0, and what we have really done here is modified this equation into this quadratic equation. And now this quadratic equation is easy to solve. We can simply split the middle term, or we can apply the quadratic formula. So let's split the middle term. So we need two numbers whose sum is equal to minus 4 and whose product is equal to 1 into minus 21. So we can split minus 4x as minus 7x plus 3x. So we get x square minus 7x plus 3x minus 21 equal to 0. And now from the first pair of terms we can take out x common, so we get x minus 7, and from the second pair of terms we can take out 3 common, so we get 3 times x minus 7, so this is equal to 0, and this means that we get x plus 3 times x minus 7 equal to 0, and from here we get either x equal to minus 3, x equal to minus 3, or x equal to 7. So which of the two roots should we pick? So x is actually Reman's present age, so it must be a positive number. So this means that this minus 3 root is not valid in this case. So the correct root is x equal to 7. So this means that Reman's present age is 7 years. And let's verify whether this aligns with what is told to us in the problem. So Reman's age 3 years ago would have been 7 minus 3 or 4 years, and his age 5 years from now would be 7 plus 5 or 12 years, and the reciprocals of these ages 1 by 4 plus and 1 by 12, the sum of these is if you combine these terms, this will be 4 by 12 or 1 by 3, and this is what is told to us in the problem. So x equal to 7 is the correct answer. Reman's present age is 7 years. In question 5 of this exercise, the problem statement says, in a class test, the sum of Shefali's marks in mathematics and English is 30. Had she got 2 marks more in mathematics and 3 marks less in English, the product of their marks would have been 210. Find her marks in the 2 subjects. So the unknowns in this situation are Shefali's marks in math and English. So let's assume one of the 2 unknowns to be x. So let's say that Shefali's marks in math, or Shefali's math marks, so let's assume that these marks are x, and because the sum of Shefali's marks in math and English is 30, this means that Shefali's English marks will be 30 minus x, because what we want is the sum of the 2 marks to be 30. So if her marks in math are x, then her marks in English must be 30 minus x. Now the problem statement says, had she got 2 marks more in math. So if she had gotten 2 marks more in math, then her marks would have been, instead of x, her marks would have been x plus 2. And had she got 3 marks less in English. So if she had gotten 3 marks less in English, then her marks would have been 30 minus x minus 3. So take out 3 from this expression, 30 minus x. So what you will get is 27 minus x. So you reduce 30 minus x by 3. And the problem statement says, if this had happened, the product of their marks would have been 210. So the product of these 2 numbers would be 210. So this means that x plus 2 times 27 minus x should be equal to 210. And this is how we can set up an equation in x in this situation, and you can see that this is a quadratic equation in x. We can solve it. We can now find the value of x, which will give us Shefali's marks in both math and in English. So let's do that. Let's expand the product on the left hand side. So we have x times 27, so that's 27x, and then we have x times minus x, so that's minus x square, and then we have 2 times 27, so that's 54, and then we have 2 times minus x, so that's minus 2x. This is equal to 210. Now let's combine the like terms. So we have minus x square, let's write it first, and then we have 27x minus 2x, so that's 25x, and then we have 54 and this 210 here. So let's bring this 210 on the left hand side. So we get 54 minus 210, so that's 164. So we get minus 164. This is equal to 0. Oh, actually not minus 154, this will be minus 156. So let's just rewrite this as minus 156. This is equal to 0. And now let's make the coefficient of x square positive. So let's multiply both sides by minus 1. So we'll get x square minus 25x plus 156 equal to 0. So this is the quadratic equation that models the given situation. Now let's solve this equation by splitting the middle term. So we know that 156 is 13 times 12. So 156 is 13 times 12, and 13 plus 12 is also minus 25. So we can split the middle term minus 25x as minus 13x minus 12x, and then we have plus 156 equal to 0. Now let's factorize this. So from the first pair of terms we can take out x common, so we get x times x minus 13 and then from the second pair of terms we can take out minus 12 common, and we get x minus 13 again. This is equal to 0. So this equation factorizes as x minus 12 times x minus 13 equal to 0, and this means that x is either 12 or x is 13. So we get two roots in this situation, and both of the roots seem to be valid values. So if we take the first root 12, this means that Shefali's math marks are 12, so she got 12 marks in math, and her English marks are 30 minus x or 30 minus 12, which is 18, so she got 18 marks in English. And then let's verify if this aligns with what we are told. So if she had gotten 2 more marks in math, she would have gotten 14 marks in math, and if she would have gotten 3 marks less in English, she would have received 15 marks in English, and the product of 14 and 15 is 210. So the first root aligns correctly with what is told to us. Now let's take the second root, which is 13. So if Shefali's math marks were 13, then her English marks would have been 30 minus 13, which is 17. And now if she had gotten 2 more marks in math, her marks would have been 15 in math, and if she had gotten 3 marks less in English, her marks in English would have been 14, and once again 15 times 14 is 210. So even the value 13 works for her marks in math. So there are two possible answers in this question. The first answer is that she got 12 marks in math and 18 marks in English. So this is the first answer. And the second possible answer is she got 13 marks in math and 17 marks in English, and both of these answers are correct.
Thank you for watching our channel. This video உங்களுக்கு பிடிச்சிருந்ததுனா கமெண்ட் பண்ணுங்க, லைக் பண்ணுங்க, ஷேர் பண்ணுங்க. மறக்காம இந்த சேனலை சப்ஸ்கிரைப் பண்ணிட்டு பக்கத்துல இருக்கக்கூடிய பெல் பட்டனை ட்ரைன் தட்டுங்க.